Welcome to SmartExam.io podcast series, turning complex concepts into clear understandings. So we're diving into the fascinating world of light quanta today, or photons, as they're more commonly known. It's a pretty fundamental concept in physics.
Yeah, light acting like it's made of little packets of energy? It's mind-blowing, right? Like, how can something be a wave and a particle?
Exactly. That's the wave-particle duality, a cornerstone of quantum physics. It's like light can't decide what it wants to be. Sometimes it acts like a wave, like with interference and diffraction.
Right. Like when you see those ripple patterns.
And other times, boom, it's all particles, like in the photoelectric effect.
Oh, the photoelectric effect. That's where Einstein comes in, right? With his 1905 theory?
Absolutely. He explained that light's energy is quantized. Basically, it comes in these discrete packets of energy, and the energy of each photon, each little packet, is directly proportional to the frequency of the light wave.
So higher frequency, higher energy per photon?
You got it. And that's represented by the equation E equals hf, where E is the photon's energy, h is Planck's constant, and f is the frequency. Simple, but powerful.
So what does this have to do with knocking electrons off metal? The photoelectric effect, right?
Exactly. See, when light hits a metal surface, these photons interact with the electrons in the metal. If a photon has enough energy, more than what's called the work function, it can kick an electron right out of the metal.
The work function, kind of like an electron's escape velocity?
Perfect analogy. And this minimum energy needed corresponds to a threshold frequency. Below that frequency, no electrons get ejected, no matter how intense the light is. That's key.
So brighter light just means more photons, not more energetic ones?
Precisely. Brighter light, more photons, more ejected electrons. But each electron's energy is determined by the frequency of the light, not the intensity. It's like each photon has to have enough energy individually to knock an electron out.
Got it. So the intensity just affects the number of electrons ejected, not their individual energy?
You nailed it. And Einstein's theory explains this perfectly. Now, let's talk about some real-world applications. Think solar cells. They work because of the photoelectric effect. Sunlight hits the solar panel, photons knock electrons loose, creating a voltage and generating electricity. Clean energy, baby!
Cool. And what about digital cameras? I heard they use something similar?
They sure do. They use CCDs, charge-coupled devices, which are basically photon detectors. They absorb photons, convert the light energy into an electrical charge, and then that charge is processed to create an image. Same principle, different application. Even in astronomy, CCDs capture faint starlight, letting us see deeper into the universe.
Wow, so this quantum stuff is everywhere. It's not just theoretical, it's actually powering our technology.